So welcome to all, myself and Arun Kumar from EC department. So in this video we are going to see how open loop and closed loop system has been played the important role in control system modeling. So especially for control systems, there are two types of systems, either open loop or closed loop systems. So these are all the systems are playing the control system modeling. So next we are going to see how the control system has been enabled for open loop and closed loop systems. So in this slide we are taken two circuits. First one is closed one and one is open loop one. So in this closed loop, we have discussed about the feedback systems. The errors has been rectified and rectified and passed towards the end of the applications. As well as in open loop systems, we are giving the input signal to the concerned electrical circuits. Then automatically it will reach towards the end without taking errors. But only the possible thing is in this case we have considered the error and rectified, and we can move towards the end. So next, requirements of a good control system. If the system is good, if the control is good, means these are all the possible essential factors we have to consider. First one is accuracy and sensitivity, noise, stability, bandwidth, speed, oscillations. If anything is missing in this above list, definitely the control may not be there, because so these are all the possible conditions while considering a control. Because if it is noise, then doesn't have any output signal. If the system is doesn't have any stability, then we don't have any output signals. If the system have proper bandwidth, it doesn't make any signals. If the system does not have any speed, then it may not reach their destination properly. The next one is accuracy. If the system is having an error, then automatically it move towards the possible combination of the solutions. So these are all the essential factor while considering a good control system. And next one is type of control system. So there are two type of control system available for cars. Either it may be a manual car or it may be an automatic car. So in these two cases, we have considered the control system as, so in manual transition we have to move towards all the gears, but in automatic transition we have to move towards the reverse or for backward forward conditions. So these conditions are also be controlled by a control systems. In next one is open loop control system and closed loop control system. Open loop control system is in the room temperature. If it is in the room temperature, it doesn't have any control because it is circulate along the room. But if you are having any controller like elements of the function system, then it may be controlled, and we can get some possible combination of heat temperature. And next is open loop control systems. In this case, how the desired input signal has been processed towards the output. So desired response, whatever it may be, we are giving the input as a controller. Then control output has passed towards the process. Then we will get the process output. Next, practical examples of open loop control systems. So see these are some examples of open loop control systems we are using nowadays. We are using this kind of control system in our daily life too. So especially for electric hot driver, automatic washing machines, bread toaster, automatic tea. So automatic controllers are, once we are giving input signal to the concerned devices, then it may be rotating, or then it may be controlled by themselves. So it doesn't have any error. If it is any error, then we may not replace. So these are some examples of open loop control systems. And next one is closed loop system. Already we have seen how the loop control system has been enabled in the system functions. So the output has been given to the feedback as to the input signal, so that we can able to get some errors in the system. After rectifying the error signal, we can move towards the output signals. Practical examples of closed loop control systems. See, these are all some examples of closed loop control systems. Automatic electric ions, servo voltage stabilizers, water level controllers, missile launched, and air conditioner, cooling system in a car. So these are all some examples of closed loop control system, especially for water level controller. It will indicates how much water need for completing a tank. So after the controller level, after it may reach the controller level, it may indicate as the water level is going to be reached or water is going to be filled. So like that, we are going to see in this case closed loop control system. We may see the concerned output of the signals. So these are all some comparisons of open loop control systems and closed loop control systems. Some of the examples, some of the possibility will not be reached in this closed loop system, especially for it is an economical prices. But in this closed loop system, it is a costly. And for open loop system, it is a small bandwidth because it require only a few frequency, only a few distance, so that it is one of the best drawback of this open loop control system. But in closed loop control system, it is having large bandwidth because we are going to see the signal of input signal. We are going to see the how much distance the signal has been reached to the destination. Next one is less maintenance, more maintenance. It's unreliable, it's a reliable. Example is hot hand driver T makers, but in this case, servo voltage, large number of controls has been enabled in this closed loop control systems. So thank you.